Assistant Professor in VVIT Engineering College, Guntur. Today in this session, I'm going to present a paper titled A Review of Scene Text Detection and Recognition of South Indian Languages in Natural Scene Images. These are the contents I'm going to present in the upcoming slides. Starts with the introduction part, then where exactly this area is useful to the people. So that is application part. Next, different types of text is going to be discussed in detail in modalities part. As I'm going to explain about the South Indian languages, for that particular purpose, Indian languages and scripts are were viewed in this PPT. Next one, approaches or methodologies dealing with how to detect and recognize the text in a scene images containing Indian languages. There are mainly two professors who worked consistently on this area. So, one professor is C.V. Jawahar, he is from IIIT Hyderabad, and another professor is V.N. Manjunatha Arachya. And their works are highlighted in this presentation. Next, conclusion and references part. So before moving on to the actual presentation, there is a need to focus on these definitions, that is scene text detection and scene text recognition. So the scene text detection means, for example, in a natural scene image, so it contains objects like moving objects or non-moving objects, living objects, non-living objects. Along with that, somewhere around there is a text. So the main target is to predict whether the text is available in the image or not. If the text is available, then there is a need to find the location of the image and enclose it by using with the help of a bounding box. And the bounding box is generally a rectangle. Next one. The output of the scene text detection is a region. The output of the scene text detection is a region that contains the text. Now, here in the scene text recognition, it is going to convert the purpose of this process is to convert to the text in such a way that that particular text is going to be edited and readable by the machine. So together known as scene text detection and scene text recognition, together known as end-to-end text recognition. So the entire architecture is presented in the form of a flow diagram here. Initially, the input image is passed to the text detection. That means whether the text is available or not. Then finding out the locations is taking place in the text localization, and separating the text from the background and non-text part is taking place in the text extraction, which is also known as text segmentation. And in order to make the text more visible and more clear with respect to the users, then enhancement needs to take place. So that's why text extraction and enhancement is one stage in the complete process. And the next one is a recognition. Recognition means, I already mentioned in the previous slide, that it takes the region that contains the text as an input and finally produces the and finally outputs the text in such a way that the text is readable and editable by the machine. And these are some of the areas where it is useful. First one is, it will be helpful to the visually impaired people. So this is one scenario. Here the bus number is 700, as they are unable to see that number. So the complete process is clearly visible to you. That is, initially this is an object detection takes place. Then in this object there is a text. The text is in the form of a number, let's say 700, and that part is detected and enclosed with a rectangle. Now the region that contains the text, that is 700, is recognized by the machine in the form of a number 700, and it is converted into the voice. Text is converted into the voice in the last stage. And another application is license plate recognition. For example, if the vehicle, like car or any other vehicle, is placed in the no parking zone, then to know the details of the owner, this one is very useful for us. And the next one, it also provides the contextual clues. It provides the contextual clues. Next, so there are different types of text and images. Actually, the main agenda is to focus on the images, that too that images contains the text, either images or video frames, but specifically each and every image must have the text in such a way that the text is divided into these five categories. So that's why those are known as modalities. So first one is printed text, second one is handwritten text, newspaper, scene image, and frames in a video. Frames in a video. So out of these five, this one is more challenging. That is scene text. Detecting and recognizing the text in a scene image is more challenging when compared to the remaining categories. The reason is this one is the best example. This is the complete image. Prior information is not there, whether the text is there in the top corner or bottom or middle, somewhere around the image, we don't have any prior information. But even in that particular case, there is a need to detect and recognize the text in an image. Whereas, just look at this particular scenario, this is a printed text. So in the printed text, the font is uniform. The font is uniform, and the layout, orientation, and the space between each and every line is uniform. But this is not the case in the scene images. So that's why detecting and recognizing the text in a scene images is more challenging when compared to the remaining categories. And here, initially, the main focus is to detect and recognize the English text, that too in the horizontal orientation. And it is slowly targeted to the images in the different orientations like vertical, slant, curve, like that. The focus on the different orientations. But in this particular conference, for every 2 years, conference is going to be held on this particular competition, detecting and recognizing the text. There, they mainly address the one problem, that is multilingual, because not only English, there are so many languages are there like Chinese, Latin, and Indian languages. So for that particular reason, there is a need to work on the Indian languages. And here I am specifically addressing the approaches that dealing with the South Indian languages. And before moving on to the approaches, there is one more reason. Not only the languages, not only the South Indian languages I am dealing with. So there is one more reason, that is in one particular paper, paper and approach, uh, there is script identification. That means before the recognition of the text, or before text recognition, script identification takes place. So this is also one of the reason I presented this information in the form of a table, that is Indian languages and scripts. Officially, there are 13 scripts and 23 languages. And also, along with the scripts and languages, here we can observe Unicode ranges. Unicode begin and Unicode end. That means Unicode range also we can observe. The purpose of the Unicode range is to synthetic generation of images. Not only Unicode, with the help of any code, it is possible to generate. That means rendering is possible if we have Unicode or any other code in our hand. That is also taking place in one more paper, benchmarking text recognition in Indian scripts like Telugu, Malayalam, and one more language, Kannada. So one paper is there. The title of the paper is Benchmarking Text Recognition in Telugu, Kannada, and Malayalam. In that, the process is to generate the synthetic images with the help of Unicodes. So for that particular purpose, in this table is having four columns: script, languages, Unicode begin, and Unicode end. And these are some of the highlighting approaches. And I mentioned based on the tasks. So first three are detection, detection in scene image, detection, text detection, scene images, and here complexity is somewhat increased. Not only in images, even there is a need to detect the text in video frames also. And one more observation what you have to made is in the first two approaches, the main focus is to detect the language in a scene image is only a Kannada. But here, all South Indian languages are detected here. And the similar approaches are followed in these three similar approach is followed in these three. First one is the Gabber filter. So please observe this Gabber filter is used in these three methodologies. In each and every methodology, the first step is that one, Gabber filter. In order to sharpen the edge and to extract the texture information, this Gabber filter is applied. And also, one more common point is wavelet transform. In order to find the locations, even here also wavelet transform is used. To find the location of the text in an image, wavelet transform is used. Then after that, wavelet entropy. See, here also wavelet entropy, and this one also wavelet entropy in order to determine the true text regions. Okay, the region that contains the text. Finally, to the output of the text detection is to extract or to obtain the region. Sorry, to obtain the region that contains the text. So, in order to get that particular region, wavelet entropy is used. But one more operation is used in this paper, that is applying or using k-means clustering and also morphological operations. These are the two more operations are performed when compared to the previous two. That is, along with the Gabor filter, wavelet transform, and wavelet entropy. Here, in this, k-means clustering and morphological operations are also used. And mostly the data sets are there are two types of data sets are used in these three methodologies, that is custom data set and standard data set, and these two are standard data sets, MRRC and MSRA. Here also for if the text is in the form of English, then this first two is useful, ICDAR 2003 and 101 video images. But for Indian language, custom dataset can be useful for them. And here also the same scenario. If the images that dealing with the text, the remaining data sets can be useful for them. 101 video images, ICDAR 2003, like that. And if at all, if there is a need to detect the text that contains the Indian languages, then South Indian language data set is beneficial for them. Next one, another task, that is segmentation. Segmentation means separating the text from the non-text part is known as text segmentation. In this methodology also, traditional approach is used. That means usage of MSER in order to get the connected components. Then binarization technique is used. In the third step, we can observe applying of stroke width transform, and SVM and RBF is used. And finally, grab cut algorithm is used to improve the recall. These are all under a traditional image processing techniques. And by using with the help of these steps, it is possible to separate the text from the non-text part. In this also, with respect to the data set, the same strategy. That is for for segmenting the English text, or in order to separate the English text part from the non-text part, the standard data set is used, that is ICDAR 2013. But for to segment, or for coming to the Indian languages, custom data set is going to be used. And especially we can observe the South Indian languages are Tamil, Malayalam, and Kannada. So for that particular reason, this approach is also highlighted here. Next one, recognition. Detection is one stage in the complete end-to-end text recognition. Segmentation is also another one. Okay, the best or the output of the segmentation is useful for the recognition also. The best the segmentation is, the easier the recognition can be. So for that particular reason, the segmentation is the uh, previous stage to the recognition. So before to the recognition, the segmentation stage is there. So here, the one more difference is up to the first four, we can observe the traditional image processing techniques. But here we can observe deep learning methodology. That is to extract the features from the image that is image region that contains the text. Here the recognition means assuming that detection already takes place, and we are having the region that contains the text. So that region is an input to the text recognition part. So features are going to be extracted by using with the help of CNN. And the next one, the sequence is going to be an output after the CNN, and this is an input for the RNN, and it is going to predict what exactly the text is. Based on the features, based on the features, the recurrent neural network is going to predict the text. But to uh, to get the or to minimize the distance, I repeat, to minimize the distance between the predicted value and actual value, CTC is also going to be used in this approach. So totally, this is a three-step process. To extract the features, CNN is used, and The output of the CNN is a sequence, and the sequence is an input to the RNN, and RNN generates the predicted text. And to minimize the gap between, or to minimize the distance between predicted value and actual value, CTC is going to be used. And here also two data sets for synthetic generation of images, synthetic scene text data set. And for the purpose of training, the first data set is going to be used. And for the purpose of testing, a new real scene text data set, triviality ILST. So these data sets, two data sets are used in this methodology. First one is used for training and second one is used for testing. And here the South Indian languages are Telugu and Malayalam. In this also, again, the traditional image processing techniques are used here, and but the task is to detection and segmentation. Here they are targeted on two sub-problems, that is detection and segmentation. In order to solve this, it is a four-step process. Initially, the Gaussian low-pass filter is used for the purpose of smoothing and to extract the texture features and edge information 2D wavelet. Even in the previous approaches also, rather than the GABA filter, here the Gaussian low pass filter is used for the purpose of smoothing, and to extract the features and edge information, wavelet transform is used. And finally, the level set function is executed for the detecting the text part, and clustering is used. So to segment for the purpose of clustering here in this methodology, the purpose of the clustering is to get the segmented characters. So the first three steps are for detection, and finally the fourth step is useful for segmentation. And in this standard data set is MRRC is used here, and the languages, the South Indian languages covered here are Kannada, Telugu, and Malayalam. Next. In this approach also there are two South Indian languages, that is Telugu and Kannada, and these are the three data sets used for this uh, like ICDR 2015, NeoCR. These are the three data sets used, and the mainly targeted on the text recognition and keyword extraction. The deep learning approach is used here. So the stages, these are the different stages. Initially, the image is corrected, then detection and candidate segmentation taking place in the second step. Then third step, recognition, keyword extraction, and based on the recognized text, the language extraction, and finally the information, the location information is going to be displayed on the screen. So the main target is to display the location information. And this is also another approach. And when compared to the previous approaches, this is somewhat different. Here, iterative nearest neighbor symmetry and mutual nearest neighbor pair. By the combination of these two techniques, uh, text is detected and recognized here. And this is somewhat a complex paper. So for that particular reason, so many data sets are used here. And even different types of text like video, scene, born digital images, three types of text can be detected and recognized. And tasks are also to text detection and recognition. And all South Indian languages, this paper is going to deal with all the South Indian languages, that is Tamil, Telugu, Kannada, and Malayalam. And finally, the conclusion is this South Indian languages or whatever Indian languages or native languages, there is a need to detect and recognize the text because It is useful for the people who are located at the rural backgrounds. And it is divided into two: before deep learning and after deep learning. So, before deep learning, the traditional image processing and computer vision algorithms are used in order to detect and recognize the text. But after the inclusion or after the usage of the deep learning, the complexity is going to be reduced. So, for that particular reason, not only for the English text, even to recognize the text in the native languages also, this deep learning concept is going to be used. The best paper is this. See, please wait. Huh. Benchmarking text recognition in Devanagari, Telugu, and Malayalam. This is one of the paper uh, regarding the Indian languages and also deep learning. So to focus on the Indian languages, and the second one is usage of the deep learning we can observe in this approach. So for that particular reason, so it is better to go for the deep learning rather than the traditional image processing techniques. And also up to so far there are only few approaches focused on these South Indian languages. So still there is a need to explore more on this research area. These are the references. And thank you.